Okay. Last page of 4.2. Okay, so let's look at 4.2, page 4. um, all right. So this one says, the following data represent the total compensation for 10 randomly selected CEOs and the company's stock performance in 2009. Okay, so here we have a list of the companies, the compensation of their CEO. This is in millions, right? So the CEO of McDonald's made $17.57 million in 2009. And these are the stock returns of the companies, right? So Exelon, whatever that is, I have no idea what Exelon is. But anyway, but it lost money, right? Middleby made a lot of money. That's kind of crazy. Anyway, but I don't know what any of these things are. It could just be made up for all I know. It doesn't really matter. Part A asks us kind of an interesting question, right? So it says, one might think that a CEO has a larger salary if the company has a larger stock return. In other words, if a company makes more money, it can afford to pay its CEO more, right? So maybe the company pays its CEO more money as a reward for the company, making more money. You could argue the other way around. You could say, well, no, a company is gonna pay its CEO more so that they attract the best talent and get the best CEO. And if they get the best CEO, then their company's going to make more money. So you could say no, CEO salary drives stock performance, right? You could make that argument, but in this case, they're trying to argue the other way around. They're trying to say if you have a good stock performance, then you can afford to pay your CEO more money and kind of reward them for their good work or whatever, right? So if that's the case, based on that assumption, which variable would be the explanatory variable? So I think you'll have some homework questions that probably are going to ask you questions like this. But anyway, so based on that assumption, right? So assuming that CEOs are paid more if the company makes money, then the thing that's explaining the other is the stock performance, right? The stock performance is explaining the CEO compensation. And so the stock return would be the explanatory variable. So which variable would be the explanatory variable? It would be stock return, right? They're using the stock return to explain why CEOs get paid what they get paid. Okay. Part B says use StatCrunch to draw a scatter plot. Part C says compute the linear correlation coefficient R. What kind of correlation exists between salary and stock return? Anyway, when we do this, since we're calling stock return the explanatory variable for this problem, I'm actually going to label stock return X, and I'm going to label compensation Y. In the homework, I think it'll be, for the most part, it'll be stated explicitly, like which column represents X and which column represents Y. But just in case it doesn't, this is what you would have to do, right? You'd have to think through, well, which one is the explanatory variable in this scenario, and then based on that, the explanatory variable is your X variable, right? The response variable is your Y. So let's go to StatCrunch. We'll enter this data. We'll draw a scatter plot. We'll get the linear correlation coefficient, and then we'll see if there's a linear correlation between compensation and stock return. Okay, compensation and stock return. Okay, so I'm entering the data. me check these. Okay, looks good. Notice that you know this CEO. So what was this? This is the CEO for Exelon. That CEO still made $12.21 million, even though his company lost money. That's kind of messed up. I wish I had that job. No, I don't. That CEO probably got fired later or something. You know what I mean? Anyway, I would hate to have that kind of pressure. Yeah, but here we go. Let's draw. So we want a scatter plot. We want the correlation coefficient, and if there is a linear correlation, we're probably going to want a best fit line as well. So rather than doing all of those things individually, again, I'm just going to do them all at the same time by going to stat, regression, simple linear. Be careful here now. So we want to compare compensation and stock return. But remember, we said stock return is the explanatory variable for this problem. So stock return is our x variable, and compensation is the y. Okay. So hit compute, and there's my correlation coefficient. Ooh, that doesn't look very good at all. That's pretty close to 0, which indicates no linear correlation. We can take a look at the scatter plot, and yeah, the scatter plot doesn't look great either, right? Like all these dots, they're kind of all over the place. So maybe, so it doesn't really seem like stock return and compensation are really correlated at all, right? Anyway, let's write this down though, and we'll compare it to the appropriate critical value so that we can determine once and for all if there is a linear correlation or not. Okay, so going back to the course notes, right, we drew the scatter plot in StatCrunch, so part B is done. We computed the linear correlation coefficient, right? So we said R is approximately negative 0.206. Okay. Now what's our sample size, right? We need to know our sample size so we can compare R to the correct critical value. Right, so looking at our sample size, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10. 10 again, just like the previous example. Okay, well, so our sample size is 10, right? And for n equals 10, the critical value, we get that from the critical value table, again, from 4.1 notes, right? This is on page 4 of your 4.1 notes. This chart is also in your book, by the way. So it's in the back in one of the appendices. Anyway, so for n equals 10, critical value is 0.632. Right, 0.632. Okay. Okay. Well, so remember, we compare the absolute value of R with the critical value. If the absolute value of R is bigger than the critical value, then there's a linear correlation. In this case, however, it is not, right? So we would say something like, since 0.206 is less than 0.632, there is not a linear correlation between compensation and stock return. Okay, so that's that. Now, before we go on, Just compare that with the previous example, right? With example 3. It's like here, R was bigger than the critical value, so there is a correlation, right? There is a linear correlation. Here, R is less than the critical value, so there's not a linear correlation. Okay, now part D says what would be the predicted compensation for a CEO whose company had a 41% stock return? Well, if there were a linear correlation between stock return and compensation, the way we would answer that question would be we would use StatCrunch to find the best fit line, and then use the best fit line to make the prediction. We plug in 41% for X, right, to make our prediction. However, there's not a linear correlation between stock return and compensation. So the best prediction that we can make for the compensation of this particular CEO would just be to look at the average compensation of the CEOs in this sample. Okay? In other words, the best prediction, Y hat, the best prediction that we can make is that Y hat is just the mean, right? It's just the average, Y bar. Okay? The way you compute Y bar is you add these up and divide by 10. Since the data is already in StatCrunch, I'm just going to use StatCrunch to do this, right? So let's remind ourselves how to do this in StatCrunch. So I want the average of the compensation column. Right, so I want the average of this column right here, the compensation. So to find the mean, that's when I go to Stat, Summary Stats, Columns. I want the mean of the compensation column. Okay. And that comes out to about 16.1, let's say 16.88. Okay. Okay, that's about 16.88. That's in millions, right? So we would say we would predict this CEO makes $16.88 million. Okay, so maybe I can say 16.88 million. Right, that's our prediction. Okay, again, that's the best we can do under the circumstances because there's not a linear correlation. If there were a linear correlation, you would find the least squares regression equation and then use it to make your prediction. Okay. Anyway, I've probably said that like 4 times now. Looking at part E, it said, what would be the predicted compensation for a CEO whose company had a negative 2% stock return? Well, again, there's no linear correlation between stock return and compensation, so we can't use a best fit line to make that prediction. The best prediction we can give is just the average, which we've already done, right? Again, Y hat would just be Y bar, which again would be 16.88. Okay. In other words, there's no correlation between stock return and CEO compensation. So what does it matter if there was a 41% stock return or a negative 2% stock return? It's not going to change how much the CEO makes because there's no correlation between those two variables. Okay. Does that make sense? So the answer is $16.88 million in both cases. Okay, so that's that one. That brings us to the end of 4.2. So again, here's your homework assignment. You just have 4 problems to do there, although probably those 4 problems have multiple parts each. But again, use StatCrunch, right? If there's anything on there that says don't use StatCrunch or do this calculation or that calculation by hand, just ignore that. Do it all on StatCrunch.